All right, let's dive into an exam question that looks super simple on the surface, but it's actually designed to trip you up. Seriously, it gets so many people. And it all boils down to one simple thing: the connection between where you are on the globe and what time your watch says. So let me ask you something right off the bat. Imagine you're traveling, right? You head due east, perfectly straight, and your latitude, your distance from the equator, doesn't change one bit. Does your local time change? Just think about that for a sec. By the end of this, you're not just going to know the answer, you're going to know why with total confidence. Okay, so to really get to the bottom of that question, we're going to break down a specific problem that shows this really common exam trap in action. And you'll see the whole thing hangs on just one tricky little phrase. So here's the question. It says a student starts at 82.5 degrees east longitude and travels due east to 97.5 degrees east longitude along the same latitude. And then it asks, what's the difference in local time? Are we looking at 30 minutes, 45 minutes, a full hour, or maybe no change at all? And that right there, that's the trap. That little phrase, along the same latitude. It's thrown in there for one reason: to make you doubt yourself. It gets you thinking, well, if the latitude is the same, maybe the time is the same too. But nope, that's exactly the confusion they're counting on. It's a classic bit of misdirection. So how do we make sure we never fall for that trap? Well, we have to get absolutely crystal clear on the difference between latitude and longitude. Yeah, they sound kind of similar, but trust me, they do completely different things. First up, let's talk about latitude. Think of these lines, the ones that run east-west around the globe, like hoops. They're also called parallels. Now, they might run east-west, but what they're actually measuring is how far north or south you are from the equator. The big takeaway for latitude, it's all about climate. It tells you if you're in the hot tropics, the chilly polar regions, or somewhere in between. Okay, now let's flip to longitude. These lines are totally different. They run up and down from the North Pole all the way to the South Pole. We call them meridians, and what they measure is how far east or west you are from a special line called the prime meridian, which runs through Greenwich in London. And here is the absolute key point, you guys. Longitude, and only longitude, is what determines your local time. So let's just lock this in nice and simple. Latitude, that's your north-south position, and it's all about climate. Longitude, that's your east-west position, and it's all about time. Two totally separate jobs. And honestly, just getting that straight is half the battle. You're already well on your way to never falling for that exam trap again. Okay, so we've established that longitude equals time. But how? How does a line on a map turn into hours and minutes? Well, this is the cool part, the real aha moment. And it's not some crazy complicated formula. It's actually just simple math, and it's all tied to the way our planet spins. See, it all starts with the Earth's rotation. Our planet is constantly spinning on its axis, right? That's what gives us day and night. And that spin, that's the physical connection, the bridge between degrees of longitude on a map and the minutes ticking by on your clock. So let's do the math. We all know a full circle is 360 degrees, right? And we know the Earth takes 24 hours to do one complete spin. So we have 360 degrees in 24 hours. Okay, so what happens if you divide 360 degrees by those 24 hours? You get 15. That means the Earth spins through 15 degrees of longitude every single hour. Pretty neat, right? But we can get even more precise. So think about it. If it takes 1 hour, that's 60 minutes, to cover 15 degrees, what's 60 divided by 15? It's 4. And that is the magic number you need to remember. Every single degree of longitude you cross equals exactly 4 minutes of time. 4. That's it. All right, now we have all the pieces. We know the difference between latitude and longitude, and we've got our magic number, 4 minutes per degree. So let's go back to that tricky exam question and just crush it, step by step. And we're going to use a super simple 3-step plan. Step 1, find the difference in longitude. Step 2, convert those degrees into time. And step 3, state the answer. That's all there is to it. Okay, step 1. The student went from 82.5 degrees east to 97.5 degrees east. So we just need to find the difference. A little subtraction, 97.5 minus 82.5, and that gives us a neat 15 degrees. And you see what we did there? We completely ignored that part about the same latitude, because for a time question, it's just noise. It doesn't matter. Now for step 2. This is where our magic number comes in. We've got 15 degrees of longitude to account for, and we know every single one of those degrees is worth 4 minutes. So all we have to do is multiply 15 by 4. And what does that give us? Boom! 60 minutes. A full hour. See, once you know the rule, it's actually incredibly simple. So the correct choice is C, 60 minutes. But there's one more little detail that's really important. Since the student traveled east, think about it, you're moving towards the rising sun, their new local time is 1 hour ahead. If they had gone west, it would have been an hour behind. Direction matters. Okay, so let's wrap this all up. I want to boil everything we just covered down into one simple, powerful trick that you can carry into any exam. This is really the main thing to remember. Here it is. This is the rule to just burn into your brain. Latitude equals climate and north-south. Longitude equals time and east-west. Seriously, if you forget everything else, just remember that. That distinction is the key that unlocks all of these kinds of questions. So from now on, when you're in an exam, these are your trigger words. As soon as you see phrases like local time, standard time, difference in sunrise, or anything about moving east or west, a little alarm bell should start ringing in your head. And that alarm bell should be shouting one word and one word only: longitude. That's what the question is really about, no matter what other distracting junk they throw in there, like staying on the same latitude to try and throw you off course. So we've seen how longitude is the master of time. But this whole system leads to a really fascinating, mind-bending question. What time is it at the North Pole or the South Pole? I mean, that's the one spot where all the lines of longitude meet at a single point. So what time zone are you in? Something to think about. Thanks for watching.